So here this is ALU used for load and store. We use it for load and store. But at that time, what is the function of the ALU? What it will be performing during load and store? We know that it will be performing addition. Why it is need addition? Because of load instruction need to calculate the physical address, okay, which is basically the sum of offset plus base. So ALU need to perform addition operation in both the cases. Another one is the branch operation, girls. So branch operation, the function ALU will be performing is a subtraction. Is it clear why it should be subtraction, girls?
Yes.
Right, it will be subtraction. It is because of we need to check whether the two registers content are equal. So here subtraction will check the result after subtraction. If the zero flag is set, it means the result is zero. If the result is zero, it means both are equal. So it is used for that. So ALU will be performing subtraction. In R type instructions, girls, it is like F depend upon the function field basically. Do you remember the function field? The last field of the instruction format. This one, if you remember the instruction format, which is here, okay? Function field, the last one. So we have opcode 1, 2, 3, then like that. So last one is the function field. So according to that one, it is decided which type of particular function will be there. So now see, ALU control is basically 1 2 3 4 4 bits, and these 4 bits is basically if 0 0 0, the function will be end, because F depend upon the function field as I just said, okay. And then 0 0 1, it will be like OR operation. 0 0 1 0, add operation. For add it is 2 basically, and 0 1 0 1 1 0, it is for subtraction. 1 7 yani set on less than, and 1 1 0 0, it is NOR basically, okay. This is the, so function field will basically decide which type of function is gonna be different. So it is like that basically. Now see in more detail. So this is ALU control, girls, and okay, just go back and see the size of the function field. Can you see the function field size? It is
6.
how many? 1 2 3 4 5 6. Yes, 6 bits, correct. Yeah, just to you can easily understand why I'm saying this one. So 6 fields are values, bits are there. So assume let me just take the pointer. Okay, so here assume 2-bit ALU op, this is opcode, ALU opcode, okay, 2-bit only, derives from opcode basically. Combination logic drives ALU control. So girls, look here, we have the instruction opcodes basically, and then we have ALU opcode. It is derived, as it is mentioned, assume 2-bit opcode derived from the opcode. We are taking 2 bits of the operation code as a ALU opcode. Then instruction operation is what? LW stand for load word, SW stand for store word, branch equal stand for branch equal, same R type. If it is addition type, ALU code will be 10. If it is R type, again ALU code will be 10. It is will be performing subtraction. And R type another, if it is AND, it will be same. So the point here, you can just see for all R type, the ALU opcode is 10, getting, and for load and store, the ALU opcode is 00, and only for branch equal, it is 0 1. Okay, this is ALU opcode, which is 2 bits, which will decide basically how ALU need to perform. Now this is the function field, girls. As I just said, you people just check it. It is basically 6 bits. Okay, so from this 6 bits, see for the load, store, and branch, it is basically don't care. And for why it is don't care? Because we don't have function field for the load, store, and branch equal. Is it clear? Because load word have immediate 16-bit offset, store also have 16-bit immediate, remember, and branch equal also have 16-bit offset. Is it clear, guys? That's
Yes.
why
Yes.
yeah, function fields are don't care. It is not there actually. That's why. But in R type we have. So in R type we have for the addition we have 1000 like that. Then subtraction 1010 like that. Addition, subtraction like. So at this set assume 2-bit opcode right from the opcode. So here girls you see these 2 bits of that one. This is the function field for these different type of instructions. Then we have here desired ALU action. What we are expecting from the ALU to perform which type of operation. So here you can see load word, definitely addition is needed. So ALU control input, what should be the ALU control input for that? It is 0010, because for the addition, because we are expecting it should perform addition. So go back in the previous slide. Then for example you can see for the addition what is the instruction? 0010, the third line for the addition 0010. So it is like addition 0010. Then again, store word, we are again expecting that ALU will perform addition to calculate the physical address. So again, opcode will be 0010. Now, for the subtraction, girls, you know that if for the branch equal, we need to perform subtraction. And for the subtraction, we need to have the ones complement of the B and something, you know that. So subtraction operation is 0110. This is the opcode for it. Addition, because of R type addition instruction, all right, it is 0010. And subtraction, it is like 6. And you can memorize even for the addition the code is 4-bit code is 2, and for the subtraction the 4-bit code is 6. And operation, it is 0, you can check. Operation or operation, it is 1. And for set less than, it is basically 7. It's like that basically. So this is the 4-bit function f, it was there, it is like that. Okay. uh, yeah, Dalia, you can have a look of sometime, it's better to check this one. I don't know maybe how this type of questions can come, so I'm not saying just to memorize all what is here, but function ALU of code you can just memorize it. Like what I just said, for the addition it is 2, you can just make a note somewhere. I'm just helping you to how you can easily memorize. Like as I said, for the addition, like it is 2 in decimal, we can memorize this way. See, this is 2 addition. For subtraction is 6 basically. You can see 6. You can see here 6. And 0 for AND operation. And this is 1 for OR operation, 7. Actually, no need for memorization, but maybe somewhere when I am explaining, so you can easily understand. That's why maybe we are not going to ask you exactly what should be the code and all, but it will help you when I will explain the complex circuitry, so you can quickly understand. Yes, yes, it is like that. Okay, that's what I'm saying. So what the point come from here, that how this ALU inputs are going to be generated basically. Okay, this table is showing like that. So go next, then see. Here we have all formats, girls. All the formats available here are load, store, and branch. Just have a look again for each of the field. This field is the opcode field, girls. Every one of you know very well opcode. You can see from here opcode, and opcode field is common for all the formats, whether it is R type, load or store type, or branch type. Getting? And for R type, its value is fixed, which is 0, girls. Understand? Opcode is 0 for the R type instruction. And load and store, it is like 35 or 43. Value is fixed. Branch opcode is 4. It is fixed. Now, R type, yani which particular particular operation here you will be performing, the function field, which is 6 bits, will actually decide. We have seen this one in the previous slide. Now the second field in R type is basically, what is that one? Source one, which is always read. Even in load, it is a source which is always read. Okay, and it is again always read. Getting the point? It is like always read. We have to read this one. Third one here in R type is the, what is that? Second source. Remember this one? Second source. Yani first source, second source, and then the destination is here. Okay, you know very well the R type instruction format. Now for the load and store, girls, this is always read. Like in case of you can see always read is mentioned. So load store instruction, and then here we have always, what is that one? Read except for load. So load, we are not going to, basically why we are saying this is always read, because here for load and store, what we have, guys, in this register? Base address, base address. That's why it is mentioned that always read. Okay, so you read the base address, which is always in the register, and then depending upon are you using store or load. Okay, so write for R type, this field, what is mentioned, this one, either this, because it's a destination, and it is also a destination for the load. So write for R type and load only. So these two will be here. It is like, if it is R type, okay, destination, this is destination, again this is destination. Okay, but what about the store? Is this the destination? No, it is not the destination. It is gonna be read at that time. So that's why it's mentioned read except for load, because in the load we have to write, which is mentioned here. Okay, it's like that. But in for the branch, girls, in the branch, here it is again need to read, and again here need to read. What is mentioned? Read except for load, because of we need to read two registers content in order to compare them. So for the branch, both are read type. This is read, but it could be here for the load and store. So if it is load, then it will be write. Otherwise, it will be read and write. Basically, I can say right there, read or write. So read in case store and write in case load. Are you getting the point, girls? Is it clear?
Yes.
Okay. Other than this, for the load, other than this, for the load, girls, this is like address here, which is offset. We know that for 16 bits. And again, this is address here, 16 bit for the branch where to jump. Okay.
Doctor,
Yes.
in the second address,
Mm-hmm.
in the store case, the first
Mm-hmm.
one, is it gonna be read?
Yeah,
Not
yeah, it's
store, not write.
yeah. See, it is always read. Why read? Because in case of R type, it is a register. Yani, what we call operand. Here is operand. Correct? In case of load, for example, in case of load, what we have here? Base address. In case of store, what we have here again?
Base address.
Base address, right? Here in branch. So branch, what we have? Operand. So everything in register here. So what we are doing always?
Read.
Always read. Understand now? All right.
Okay, thank you.
But this is the way. This is the way. Okay. So okay. And the second one we have seen already. It is again read because we need two operands here. It's two operand read. And this one also read in case of store, because we have to read the content of T and then we have to store there. So read in case of store, but write in case of load. This is the way. Okay. And here it is again read. So both read here. So this is the format and how it is happening there next. Okay. Now guys. So here we have data path with with controls here. So we have seen the previous the full data path. Now it is with full data path will with the control lines also. Okay, just a minute. Can you see the screen now? I think there is a disturbance. This is like that. Okay. So you can see guys, these control signals are very important to understand, because this will be we will be asking you what should be the control signals according to the instructions. So can you see how many control signals are there, girls? Register destination, branch, memory read, memory to register, ALU opcode. We have seen girls, ALU opcode, 2-bit opcode. What was that? Do you remember 2-bit opcode? Can you see this line is little bit thick compared to other one? Can you notice this?
Yes.
Yeah, it is because of it is basically 2-bit. It is 2-bit long. Otherwise, all are here 1-bit. That's why it is thick. And why it is 2-bit? This ALU opcode. Go back and see what we discuss here. Are you getting my point? Because ALU opcode is 2-bit code. So that's why it is bit thick. Okay. And basically, if you here go back again, check, and you see this is ALU control, girls. What are the inputs for the ALU control? ALU control, there are two things. What is this one? What is that? ALU op. And what is another one? Can you notice this one? Instruction 0 to 5. Instruction 0 to 5. This is what basically 0 to 5. Is this the function field or not?
Yes.
Yes, it is function field, which is here. Go check. 0 to 5. This is the one. Getting my point? So ALU control is having two input. One is ALU opcode. Another one is function field. Then it generate the ALU input, yani this one they will be generating. So using this and this, then it will be generated. This and this, it will be generated. We'll discuss these things in detail. Just you can just understand that ALU control required ALU opcode, which is 2-bit long, and it requires function field, which is 6-bit long, to generate ALU control inputs. Okay, now see this. So these are the ALU control input, which is 4-bit. We know that one, right? 4-bit. So this is how it is designed. We will see the internal circuitry later on. So this is overall any connectivity along with the control signals, and each control signals are connected to each and every data path here. Okay, let's see now. Discuss. We were discussing about the ALU control signals, how it is generated. So it is clear to you there are 2 bits coming from the ALU, from the control, and 6 bits are coming from the instruction itself, from the function field. See now what's now. Please have a look here. It's interesting and important also. So control unit. Okay, this is the control unit. And for the control unit, go back and see one more thing in the previous slide. See that what is the input for the control unit. Can you check? What is this?
Opcode.
Opcode, exactly. It is the opcode. And opcode field is common for all 3 type of formats. So these 6 bits, basically the input for this control unit, girls, in order to generate 9 control signals. I am saying 9. Can you count it? 1, 2, 3, 4, 5, 6, 7, 8. By the way, ALU opcode is 2-bit. That's why I said 9. Okay. If we just consider A opcode is as a single, okay, if it is, we consider as a single, so we can say any 8 control signals are there. And one of you asked me, daughter, do we need to memorize the code? See, sometime if you are not memorizing, so at least you can understand if the instructions are R type, okay, we need to understand if it like either 0, 1, 0, or we should know that it is an addition. Getting my point? Or if it is 1, 0, yani it is performing subtraction, yani instruction is sub type, so this should be subtraction. Yani, see, and it is always 1, 0, but in case of instruction operation, we should know this thing, and we can tell even if we are saying it is add instruction. So we can say that this function field like performing addition, it's like that. Okay. Just give me a minute. Just give me a minute. uh, all right, so just continue this with this and this, and okay, so see this one, guys, control unit. So the input is op field, which is 6 bits from the instruction register. The output is 9 control signals. As I said, it is 9 control signals. So girls, we can see this table. In this table, we have this control inputs. What are these? These are basically 6 opcodes, which is like op0, op1, op2, op3, op4, op5. Yani opcode 1, 2, 3, 4, 5, all 6 bits are here. So girls, look, as I just said before, for the R format, what should be your opcode? Should it be 0 or not? All 0? It's all 0. Okay. And for the LW, we have seen that it should be either 43. What was that? I'm going back and just checking this one. Just please have a look here. 35 or 43. For the load is 35 and store for 43. And for the branch, it is basically 4. Let's see there in this table. So here we can see for the load, this is the code. Opcode field, store, this is the opcode field, and BEQ we said 4. Check it, this is 4. Start read from the up to down. So it is 100, the last bit, which is 4. Now girls, the outputs, how they are generated, we have to just focus these on outputs. So regarding the output, girls, if it is so register destination signal, if your function is R type, basically instruction. So girls, do we need a destination register in this case?
Yes.
R
Yes.
type. Yes, exactly.
Yes.
Because R format requires 3 registers and 1 is the destination. So this signal is 1. Getting?
Yes. Yes.
All right. What about the load word? Do we have registered destination in case of load word?
No. No.
No. So that's why it is 0. The registered destination is what basically, which type of signal is this? You can check it. See, registered destination, I think better if we just read first this down. Registered destination, which field of the right register? It's like that. Branch control signal, set when instruction is branch. Okay, it will be just only one. Then ME memory read input address from the memory. Next, memory to register, source of the register, port to where are these basically? You go back this slide and you will understand. It is there all. Not this one. Here. And just let me remove this all. No, you can have a look here. So let me rest. Now check. So this is register destination, girls. This one first. It is connected here. You see, it is connected here. Okay, which is basically telling what is the second operand basically. Yani, as we said in the previous example, what was that? The slide. The second one could be could be this one. In case of, we have seen, it could be read or write. In case of load and store, I read, or it can be except for load. Yani what, and see that the values is 16 to 20. 16 to 20 is the bit number, bit positions basically. 16 to 20 the bit position. So see this one here. Yani here first register is exactly no problem for the first register, but the second register, here we have to decide this one, which one is the right register you are going to write. Is this coming from 16 to 20, or is it coming from 15 to 16, 11 to 50, sorry, 11 to 15? Which right register is this? So depend upon the instruction. Okay, depend upon the instruction, which one need to be choose as a right register. Go back and again you will see. See girls, either this is the right one or this is the right one. Are you getting my point? This is 11 to 15 will be selected if the instruction is R type to write the register, or if the instruction is basically load. Yani basically this one will be the right for the R type and as well as for the load type. So if our instruction R and load, then it will be the right register. So here is the point. Here is the point. Yani this will be the selection for the right one if it is basically either R type or the load type. So accordingly, according to that one, this signal is gonna be 1, and then it will be reach here, 1 or 0, whatever, and it will generate accordingly. And then it will decide whether need to choose this one or need to choose this one. It is for that. Are you getting this point? Yani it should be yani right signal, right register number should come from bit number 16 to 20, or it should come from 11 to 15. It will be decided by this register destination. Okay, and here is that one, which should be like that. Check. Is this that one the destination register? Yani it will be in case of which one? It in case of load register, because we have to bring the data in what we have to write this register. So if your instruction is load, we have to choose this. If your instruction is R type, we have to choose this. Are you getting my point now?
Yes.
Yes.
Right? So if the instruction here, what I was explaining to you, if I say girls, the instruction is R type, okay, what should be the register destination value? R type means we have to choose this bits for the register number. Okay, it means this value should be 1. Am I right?
Yes.
Okay, if it is load type instruction, so we know that for the load type, this is representing the right register number. So we should choose this one. So what should be the register destination value? Should it be 0 or not? Because we have to connect it like that. Input 0. Clear?
Yes, clear.
Okay, so this is the way. So according to the opcode, girls, these 9 signals are gonna be generated. We'll see now with an example. If this is the instruction, what will be the control signals and all. Just give a time, then I'll explain. So this is what you can see here. According to basically that instruction type, if it is R format, you can see these are the instruction values of the all control signals. By the way, see now ALU opcode is now split into two. ALU OP0, OP1 to show you that this is basically the, and what I said in all together as a 2-bit 10, I said 10. It is 10. Read from up to down 10. And for the load word, it was 00. See here, it was 00. For the store word, it was again 00. But in case of BEQ, it was 101. It's like that. So now it's break. So here is a point. You can see all were either 0 or 1 except these two. Registered destination is don't care here, girls. In case of SW and in case of BEQ. The reason is that, are you choosing the destination for SW, girls? Store word. No, we don't need to write this time. Am I right, girls? For the store word, we have to store, not write. So it means we don't care about this signal, neither be 0 nor be 1, because of we are not going to write the any register. Are you getting my point?
Yes.
Similarly for BEQ, we are not also going to write any register. That's why it is don't care. If it is not clear, go back to the previous slide to understand that one. See here again. Because for the branch, we are not going to write any register. Just read this, no write. That's why that control signal is 0 for this, and when you don't care for it, because not required. Similarly, for the store, we have to read these two registers. So we are not going to write in the register, we are going to write in the memory according to this offset address. So we that's why we said for store and for the BEQ, this signal is don't care, neither 0 nor 1, because 0 means we have to choose another field, 1 means we have to choose another field, but we are not going to choose any field according to this slide. Also you can check, because we are not going to write any register, so neither we will be using this 20 to 16 to 20 nor 11 to 15. So that's why this signal is don't care. We will be not saying either 0 or 1. Is it clear now? Register destination should we don't care. It is because of we are not going to perform write operation in case of store word and in case of branch EQ or BNE. Girls, are you getting?
Yes.
Yes. Any confusion, you can ask me, no problem. Okay, you can ask me, you can stop, because we are not performing register writing operation. That's why we do for the SW will writing the memory, but we are not going to write the register. That's why here we cannot say 0 or 1, 0 or 1. It is like don't care in case of these two. Okay, which is there. Need to understand. Once it is understand, inshallah, thing will be more clear. Now, guys, again, one more time, you can see this is don't care, don't care. Please look here, memory to register. Which signal is this? Just go back and check. Memory to register. Where is that one, girls? Memory to register. Is this the one? And it is connected here. Yeah, this is the signal we are talking about. So, girls, here it is choosing which data is going for the write back in the register. So two ways, either the data is coming from the memory or it is coming from the result of the ALU. Are you getting my point, girls? This one?
Yes.
Okay, so this signal will choose memory to register, yani whether you are getting data from here or you are getting as a result, yani it will use whenever you are writing some data here. But if your instruction is not write type, yani if your instruction is not performing write operation, so do I need to use this signal? This is my point. This signal will decide which data need to be written in the register. Are you getting my point? This is here. But if your instruction is not writing type, yani it's not writing any information in the register, so this signal should be don't care. Are you getting my point now?
Yes.
See, if I say LW, are you writing in the register or not?
No.
Check it again.
Yes, we are.
We write LW. How do we write LW instruction? We write LW dollar T naught comma constant any value, then S6. So we calculate physical address, and then physical address we bring the data and store in T naught. So writing is there. Am I right, girls? So for
Yes.
that one, correct. For that one, now my point is here. What should be the signal of value of this one? Can you tell me now? Signal value of this memory to register.
1.
It should be 1. Yes, exactly, because the data is coming from the memory, so it should be 1. Exactly, absolutely right. What about add instruction? ADD dollar T naught comma T1, for example, and T naught. Now, girls, what about the addition?
0.
0. Yes, exactly 0, because of the result is coming from the ALU output. Correct? This is the way. So, girls, other than these instruction, what are the instruction? This is called R type. Am I right? Another one is load. What is remaining? Store type. Girls, in the store, do you need to write the data in the register for the store? Think. How do we write a store instruction? SW?
No, we
T
don't
naught?
have to write in the register.
Exactly. We don't need to write it because we have to write already the content of T naught into the memory. Exactly, right? So we don't need to write the register. So what do you think? What should be the value of this signal memory to register? Should it be don't care or not?
Yes.
Yes.
Neither 0 nor 1 we have to choose this time. That's why it should be don't care. Exactly. You get my point. Another instruction, which is like branch equal BEQ, girls. Here we say dollar T naught comma dollar T1, then we say label. Girls, in this instruction, are we writing any register or we are reading to register only?
Only reading.
Only reading, right? And then we test the result accordingly, 0 flag will set. So again, do we need to choose here this signal as a 0 and 1?
Don't
No.
care.
No.
No.
Don't care.
Don't care. Yes, exactly. Now this is the point. So now you get my point. You know why I explained this one, why I took this much of time? Because what is here, what are the type of questions gonna be there? It is about all understanding, how these signals are gonna be changed and all. Because we are not going to ask you design this one and draw this circuit. No, here question will come analyze type. Question will come synthesis type. Yani you need to analyze, design. Designing also possible. Yani we can skip any signal, anything from here. We can ask you how it will be designed. Yani we can ignore, remove something. So understanding of this one is very important. We will be providing you this picture itself, figure itself, diagram itself, but we may remove something, we can ask you something related to that. So this itself is very important. That's why I'm giving time here to explain you in detail. See now. So hope it is clear why these two signals are don't care. For the SW, register destination, and the BEQ. Rest is 0101. Yani we are using it. Correct, guys? Inshallah, we'll see these things in detail with the each and every instruction. Inshallah. Okay, and what are the meaning it's mentioned. Then next now we can move to the next step. And what is next? Okay, guys. This is basically the control unit. Okay, and how it is implemented, now you will see, and how the control unit is generating these 9 control signals, girls. So you can just have a look here. These are the opcode, 6-bit opcode, girls, which comes here. Then we have AND gates, inverted AND gates. R format, this is generating from here. This is LW, this is SW, this is BEQ. Then 11, sorry, 9 control signals are there, which is coming like that. You see this one. Okay, this is that. So this circuitry is basically inside the control unit, which is generating these 9 control signals according to the opcodes. So opcode is the input for it. Okay, this is something. Now, another thing is ALU control. I am coming to the ALU control because I explained to you in this slide, girls. You look here that ALU control have 2 inputs. One is 2-bit ALU op and another one is the function field, as you said in the beginning. Okay, so 2 inputs, then they are going to generate this 4-bit code here. So how it is generated, we'll see now this one in detail. See this one. So this is the one. So ALU control. So the ALU control has 2 inputs, as I said. First is ALU 2-bit from the control unit. It is coming from the control unit. Then the function field 6-bit from the instruction register itself. Then ALU control has 4-bit output. As I said, it is 4-bit output. How it is generated, girls? See. So 2-bit coming here. OP0, OP1. It is like connected upper this one and this one too. And this is 0 to 5. Okay, function field, it is connected here. And then, and by the way, in function field, we are not using all 0 to 5. Can you see what we are using? 0, 1, 2, 3. Still 2 are remaining. So we are using only 4 bits of this function field and ALU 2 bits. Then we are generating here 4 different opcode, operation code 0, 1, 2, and 3, which is basically ALU control signals. So 0 bit is this one, 2nd bit is this one, 3rd bit is this one, 4th bit is this one. So according to this logic, ALU control block, it is generating basically the operation. So if 0, 0, 0, it means function is AND. 0, 0, 1, it is like OR. As I said, for the addition, it is 2. For the subtraction, it is 6. And for this one, it is 7. And for the NOR, 1, 1, 0, 0. It's like that. So ALU control signals will be generated from the ALU control box. This is the ALU control. Is it clear? Any question, girls? Clear. Should I continue the lecture and leave you early? Or do you need a break? I can leave you around early. Or if you want
Early
break.
with how much, Yani?
Okay, 2:25. 2.5, yeah, around 2.5.
It's okay for me, but I don't know about the other students.
All right. Okay, girls. Is it okay or?
Doctor, I prefer to continue.
All right.
Other student.
Okay. So maybe others are already silent. It means all are agree to continue. Okay. Fine. Okay, girls. See now, girls. So it is very important. Please, I need your attention here. This type of questions have been asked earlier also in the exam, which is in front of you. See, all of you, I need your presence here. So here is practice question for you. This is the R type instruction, girls. You can see it is R type. Now here already instruction is given to you. What should be the instruction? And for this instruction, girls, this is the instruction. The instruction is add S0, S1, S1. You have to perform this. And now you have to tell 8 control signals. A1, 2, 3, 4, 5, 6, 7, 8. ALU opcode also, you should tell what basically ALU is performing here. Which type of operation is gonna be performed. So right, as you said, teacher, should we memorize the code 1001? Okay, if you not memorize this one, you leave it. But at least what you can tell here, you can tell exactly which type of operation ALU will perform in terms of addition or subtraction. Getting my point? Okay. Now check for now. What about the register destination, girls? In case of add instruction.
There is a registered destination.
There is a registered destination, exactly, because of we have to write S
The
naught.
outside, يعني it's already.
Okay, now there is, yani it should be 0 and 1. Now you have to choose, it should be 0 or 1, because are we going to use these bits to choose the register, destination register, or this one? Which one?
One.
Blow, right? 1, exactly. So 1. So what should be the registered destination value? Should it be 1 or not?
Yes, 1.
Very good. So you got it. Second one, ALU source. ALU source. Check it. This is that signal, girls. Yes.
0.
0. It is because of, may I know the reason? Because the second operand is the register. Is it clear?
Yes.
Okay. Because second operand is the register. It's not the immediate value. Are you getting? If I say, for example, A, D, D, I, and then I say S naught, comma, S1, comma, 2. Are you getting my point?
Yes.
So at that time, what about your second operand? Is this the register or is this the immediate value?
Register.
In case of immediate value, this will be not the, we will be not getting this one. This will be coming from this way, right?
Yes.
So it should be 1 at that time. Getting point?
Yes, clear.
Okay. So now, because of it's not here now, just focus first what we are explaining. Okay. So here is that one. S naught. So ALU source, as she said, 0. All right. Now, girls, memory to register. What should be the value of this memory to register? Okay. Memory to register, yani this one. All right. So it should be 0. The reason is because we need to write the result from the ALU, not from the memory. Correct?
Yes.
Yes.
All right. It is 0. Very good. Then register write. Register write. Where is that signal? This one. Are we going to write? Yes. Are we going to write the register? It's enable signal. So it should be 1. Yeah, it should be enable. Right. Exactly. It should be 1. Memory read. Yeah. Any question?
I have a question. Memory register. Why did we choose it to 0?
Memory register. Which one?
The third.
Memory to third one. Memory to register. This one, right? So from where you are going to get the data to write in the register? Are you getting from the? Are you getting from the memory or are you getting from the result of the ALU?
ALU, I think.
ALU, because ALU is performing the addition of 2 registers, S1 and S1.
Okay.
Then the result is available here, right? And then we have to choose this path, and this path is connected on 0. That's why it should be 0. Clear? Okay. All right. Now, what else we were discussing? Memory register. Yes. MEM read. Memory read. Now tell me, memory read. Where is the memory read register signal? This is memory read. Yani this one.
0.
Because we are not reading memory. Exactly. Right. It should be 0. We are not reading the memory, so it should be 0. Exactly. Okay. What about next?
Also
Memory, memory
Yeah.
write. We are also not writing the memory, so 0. Branch is very simple, girls. Is this a branch type?
No.
No, 0.
No, so branch is here, this is here. So it will be 0. It will only be 1 whenever you have BEQ, whenever you have BNE. What about the ALU opcode? So here you don't need to memorize, but you can tell the operation of the ALU. What type of operation ALU will perform? Will it perform addition or subtraction?
Addition.
Addition. So you can write here, that is sufficient. And also for the addition, do you remember the code as I said?
2.
Yeah, 2 exactly. But it is only 2-bit, na? So I should write 1 0. Are you getting my point?
Yes.
Yeah. So for all R type instruction, because it is a R type, right? It is 1 0. So either you can write this or you can write this. Both are correct. Is it clear?
Yes, clear.
Okay. But for example, if this instruction is sub, so 1 0 is exactly correct, no problem. But add is correct at that time.
No.
Will LU perform addition? No. At that time, what we will write? Sub. But this code is same, 1 0. Is this clear?
Doctor, how register destination, the first one, to become 1?
Yani, were you sleeping that time? I am explaining everything one by one by one by one. Then I
understand
repeat.
all of them, but the register destination, I didn't get it.
Okay, just wait for it. Because I explained that time, and better you ask your question, at that time. No issue, I will explain. So is this clear, girls? If it is subtype, so 1 0 is correct, but it will be not addition. It will be like subtraction operation will be performed by the ALU. Clear now? Up to here? Yes.
Why did you say that it will be the same for sub also?
Okay. Why I said why it will be 1 0, right?
Yes.
Okay. I'm saying it is because of check this. Can you see for all R type, for all R type instruction, what is the ALU opcode?
1 0.
1 0. Clear?
Yes, it's clear.
All right. But in terms of like if you want to write action, see, if you write action, so you will say if addition, you will say add. If subtraction type instruction, you will say sub. If it is like AND or instruction, you can write AND. Or you can write or. But it's easy if you can also mention 1 0 for all R type of instructions. Clear?
Yes, it's clear.
All right. Okay, so now move to the one which I was explaining, and there was a question related to the first one. Okay. So here you were asking question why register destination is 1. Okay, this is the confusion. Okay, focus here now. So I told you, we can see that by reading this, whether this is R type or which type of instruction format is this. So when you say add, so it is clear that it is a R type. Clear?
Yes, yes.
Okay.
Clear.
For the R type, go back and see here. Here. In the R type, if you look closely, so which is the destination field here?
15.
11, 15. 11 to 15, right? This is the destination. All right. So it should be. But if it is another one, which is load, which is store something, load one, sorry, load, it should be 16 and 20. So you know that we are discussing add instruction. And for the add instruction, the destination, yani the write register is gonna be 11 to 15 this way. This field will represent the right register number. So we go there and check here. So when you look here, there are two options. Which one we have to choose? Because for sure we have the destination, which is S0. We are going to write. So which field will tell? Because it is a R type, and you know that R type, this field will tell the register number which you are going to write. Am I right?
Yes.
Okay. So this is the mux, and mux will choose either this one or this one.
Mm.
So if you want the below one, it should be 1. If you want upper one, it should be 0.
Okay.
Clear?
Yes, sir. Now clear.
All right. Okay, girls. So this is the complete explanation of this practice. Okay. Any question, girls? No question? Okay. So, all right. So this is the answer. It's not there in your slide, but now it is there. You can note it down. Okay. In place of add, you can simply write 1 0. That is perfect if you write that one. Because of all R type, 1 0 will work. But if you add that time, it will be not like that. Okay. For the addition, we have different number. But what ALU will perform, you know that for AND operation, it will also perform the same. Okay. Next, you can write here and now, guys, one more example. You will tell now, or one by one. Who will tell one? Anyone of you can check and tell me.
The first one is 0 because it's not an R type.
Okay. If not R type, but see, first I think you should check register destination. Are we going to write the register? Think in a way. Yes or
I
no?
think yes.
Yes. If yes, so which field will tell you the right register number?
The first one.
First one, yani 16 to 20?
Ah, you mean, I'm not sure one.
Yes.
Let me see.
Yes,
because it's low.
20.
Yeah, I just explained. So again, let me start explanation. First of all, when you see the instruction, girls, you check it first. Is this writing some? We need to write some register
Yes.
in this instruction. Yes, we are
Yes.
going to write the S0. All right. So if it is load type, I told you there are two instruction where you have to write. One is R type. Another one is load type.
Load.
Clear, na? Okay. So both we have to write. Now, if it is R type, so it is basically the bits 11 to 15 will tell the register number in which you have to write. If it is load type, so register the bits 16 to 20 will tell you which register we have to write. Clear, na?
Yes, clear.
Okay, so what should be the register destination value now? Because we have to write. So this here we have to choose here, correct?
Okay.
So what should be the value now?
0.
0, because here is this one. Okay, this signal will be 0. Why? The reason is because 16 to 20 bits will tell the register number, so it will be 0. Is it clear to all?
Yes.
Yes.
0. Next, ALU source.
1.
ALU source, you are saying 1. Okay. Okay. Check. What about others? She's saying ALU source, yani this signal should be 1 because of the second operand is the immediate one. Immediate, you can see, girls, this is 12. 12 is immediate or not?
Yes, yes.
Yeah, immediate.
Yes.
Correct? Getting the point, right? Because ALU will add these two things together, right? So immediate values. That's why the source has to be 1. Exactly. You give the right answer. Good. Next, memory to register.
1.
This is the memory to register signal. MashaAllah. It is 1. Should it be 1, girls? Agree?
Yes.
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 Because we are getting data from the memory, right? We are reading the data from the memory, right? So that's why it is 1. Exactly 1. Next, register write.
Yes.
1.
Register write this one, right?
Mm.
No, not this one. Register write is should be 1. Then this one, right? Yes, because we have to write the register. So that's why it should be 1. Exactly. Correct. Then memory read. Are we reading the memory?
Yes.
Yes.
Yes, we are reading the
we need
memory.
to write.
Yeah, we are reading. And it should be 1. And enable. This one has to be read. This one is the read. You can check. Okay. Are we writing the memory?
No.
No.
No, we are not writing.
Register.
Yes, we are not writing the memory, but we are writing the register. So this is gonna be 0. Is this branch type instruction?
No.
So exactly 0. What ALU will perform? Which type of operation ALU will perform? Addition, subtraction, add, or right, whatever.
Addition.
Addition, add. So here you can write ADD. And what else we can write?
1 0.
1 0. For the addition, we know it is 1 0. Clear up to now to all of you?
Yes.
Easy? Easy? Okay. So basic understanding is very important. And once it is clear, yani, it is so easy to understand. See what you said, all answers are here, exactly same. All right, one more. So this time either BEQ or BNE, and it could be anyone, and we have given something. We have again asked to fill these register number values. We have to choose now. Starting with the first one, and you have to check, are you going to update any register, going to write any register?
No.
No. If you are saying no, then it means is that register destination neither be 0 nor be 1. Getting my point? How many operands we have here? We are no. 1 minute. Yes, correct. Because we are not writing, correct? So we don't need any register to show right here. We are reading only, correct? So we are not writing. That's why register destination, this signal, which is here, right? What it should be next? Should it be 0? Should it be 1? No, we don't care it because we are not going to write the register. Are you getting?
Yes.
So it should be
Okay.
Don't care.
Don't care.
don't care. Exactly. It should be don't care. What about ALU source now? What about ALU source tells you the second
1
option?
because we have the 120. I think.
ALU source is this signal. See, first look here. This is the ALU source.
Okay.
So what is your second operand? One operand is this register which is coming from here. What about the second operand?
It be 0.
Is it the register or not?
Yes.
Again, second register, 2 register. So it should be 0 or not, so that this will go 0.
Yeah.
Correct? This is the way. Tell me the second one.
Don't
0.
care.
Yes, don't care.
Okay. So it is memory to register. So now girls, this instruction not dealing with the memory. So it is like memory to register, like this one. This one. So neither we are going to read the data from the memory, nor we are going to take the data from the ALU to write back because it is not involving the write back. That's why. Should it be don't care or not?
Yes.
We cannot say 1 because we are not reading from the memory. We cannot say 0 because we are not getting from. We are not going to write back. It means this is going to be don't care. Very good.
Okay.
Yes.
So if it's neither 0 or 1, I put don't care.
Yeah, it means is that because don't care means it is not fixed. It is not fixed. It is not decided whether it is 0 or 1. Okay, that's why it is don't care. It could be any value because it is not basically going to affect our operation. Getting my point? If it is 0, if it is 1, it is not going to change anything for us because we are not reading from the memory. We are not, getting the data from the ALU source. That's why.
Okay.
Next is register write.
0.
Are we writing register or not? Yes.
No.
No. Okay, we are not writing the register, so it means disable. Correct or not? This signal. Disable.
Correct.
Yeah, disable. All right. Memory read. What about
Doctor, why
memory?
we didn't type don't care and register right?
Sorry.
Register right. Why we didn't write don't care?
So are you not going to tell whether you are enabling or disable? Are you not using the register file in this operation?
No.
Who said? Are you not read the register file in the beginning?
I
And
will
now,
read, but I didn't write in the register.
okay, so that's why it is 0. Because this is enable or disable. When it is 0, it means disable. When it is 1, yani enable. Yani we have to either specify 0 or 1. Getting? When it is 0, it means disable. So that's why we say disable, and we are not writing anything. Clear?
Yes.
Why do we make here don't care? The reason is neither we are using this nor we are using this. That was the reason. That's why we say it is don't care.
Yes.
Okay. Now memory read. Are we going to read the memory?
No.
No. So what it should be?
0.
Okay. Also, are we going with the? Are we going to deal with the memory in this operation?
No.
No.
No. So it can also be any, but because it's better to say these which signal will be don't care, by the way, just to let you know. Sorry, what is that? Here. Which signal will be the don't care, girls? You can see in this chart. There are 2 signals which should be the don't care. I told you. Which are the signals? Can you check it again?
Destination.
This one, right? Register destination and memory to register. These are only don't cares. Rest are either 0 or 1. Okay, so keep in mind also. So it should be clear to you once you have this thing in your mind. So girls, we were discussing this. So memory write. Are we writing the memory?
No.
No. Is this branch type?
Yes.
Is this branch type? Correct. Yes. So see what will happen. This signal is gonna be 1. Are you getting? And the result will come another result of 0. Depend upon the value because it will perform S0 minus S1 if the result is 0. So result yani 0 flag will set to 1. Getting my point?
Yes.
So 1 and 1. What will be the output here?
1.
1. So this one will be connected here. Yani what is coming this one? This is the branch calculation we have discussed in advance. What was that? 16 offset, which is here, gonna be sign extend. Let me take the another color so that it will be clear to you. This 16, this one, just a minute. See, this one 120 will be first 16-bit long, going to be sign extended. After sign extension, we need to shift twice left, multiply by 4. Clear? And then PC plus 4 is coming from here. So PC plus 4 and this one will be added and it will generate your target address. And then target address will be loaded in the PC. Getting point?
يعني.
Yes.
Yeah, this is the way how it will be working basically. Now, the last one is remaining, ALU opcode. What it should be?
Subtract.
Subtract. So what we can write?
1 0.
Sub is okay or not?
Yes.
For the 1 0, go back and check what it should be for that one. See, just a minute. Branch. What is the code for it?
0 1.
0 1. So that's why I said you may get confused with that one. There are only 3 codes. If you want to remember, memorize it. So 0 1 for the branch equal. Clear, girls? Another one, 1 0, which is for all R type. Clear?
Yes.
And the third class is the load or store. For that, 0 0.
0 0.
Easy now? Easy. Now you can memorize, I think, easily. If this is store or load, it will be 0 0. Okay. And if it is branch type, it will be 0 1. And if it is R type, it will be 1 0. Or you can also write, because load and store, we need to add. So you can write the action itself. Branch equal, subtract. I write SUB there. Did you get my point?
Yes.
Yes.
Okay. Then R type, if it's addition, you can write ADD. If it is subtraction, you can write sub. If it is addition type, either you write 0 1 to make it easy, or you can say A and D and operation, or again either 0 or. So which one is easier for you? You just write it. So I think 2-bit is easier. Which one 2-bit I am saying? This one. This one, another, and another. This one is easy. 3 class. This one you will memorize for these 2. This one for this one, and this one you will memorize for 1 0. I think it is more easier than add, subtract, or something like that. Is it clear, girls, now?
Yes.
Okay, so you can just note it down. Yes, only because 3 options will be there. Either you will write 0 0, or you will write 0 1, or you will write 1 0. It's like that. Okay, it's so simple. Now, but one more example is there. Then I will stop after that example. Practice 2, 3, and this is the last one, and it is opposite, girls. Opposite. This time I'm asking you, by giving the control signal, which type of instruction is this? You don't need to write the complete instruction. Listen, you don't need to write the complete instruction, but you need to tell, is this branch, is this load, is this store, and or whatever. Okay, think about it.
Maybe add I.
Add I.
Because it's similar to the first one we did it, but with the ALU source.
Oh, so how can you check it? Better you just focus on this first any destination. It means is that it is R type. Are you getting my point? It is R type or load type. Both possible or not?
Yes.
These 2 are possible. Okay. Now ALU source is 1. Yani
Immediate value.
immediate value, exactly. ALU source is 1. Where is that ALU source? Yani this one. Yani immediate value. We are saying this immediate value. And girls, immediate value, it means it. Do we have immediate value in LW? Yes. In LW we have immediate value, and in R type we have also immediate value. It could be like add. Are you getting my point? Because the operation is already add, so it could be add immediate. Getting my point?
Yeah.
Yes. Again, go further, analyze more. Memory to register, ME to register. So any this one, they are saying 0. It means what they are saying? Result coming from the ALU. Yani more chances to have this one, because load will not take this one. Load will take the data from the memory. Are you getting my point?
Yeah.
All right, so that's why we can say it is like add immediate. You want to make sure more, go further. Because of branch 0, yani it is not branch type. Okay, memory write. Are we writing memory? Because it is not load type. Memory write is saying if it is load type, we need to write the memory. No, sorry. We need to read the memory. Are we reading the memory also?
No.
We are not reading the memory. It means it is not the load type. Getting?
Yes.
Because in load word, we have to read the memory, correct? And we are not. Register write. Are we writing the register? Yes. And where we write the register in case of our type, which is add immediate. So this is add immediate. Clear? Okay, we don't need to write here exact further. Further yani add immediate is sufficient your answer. If you want to write further, okay, so register is not given, actually numbers are not given, so how can I say whether it is T0 or next one is T1, next one is T2? We cannot say. So just ignore this one, just write the instruction basically, add immediate, that is sufficient to give the answer of this one. Yes, is it clear to all of you until here? Clear? So I think we have discussed all the type of instructions and how the control signals are affecting. So girls, what we just discussed, it is the summary of all. Please have a look here. This is R type instruction. You check. R type could be add immediate, sub, and or like that. So this is like that. So these are the signals. 1 0 we have seen. Load word, we have seen for the load word that this is something, and the 2-bit code will be 0 0. We have discussed. Store word, for the store word, register destination and BEQ, they will be don't care. Okay, and even one more thing, if I give you opposite question and if you find somewhere don't care, you can easily understand that either it is SW and BEQ. Am I right, girls? If you find okay, if you find register destination and memory to register, they are don't care. It means you can quickly strike in your mind either SW and BEQ, right? Now, then you check this control, which is branch, and you know that it will be one only for the branch. Getting my point?
Clear.
Okay, so if this is 1, this is 0 0, you can quickly say, okay sir, this is BEQ type instruction. It could be BEQ or BNE, whatever. But if it is 0, for example, you can quickly say, okay, this is SW type. Easy now? You understand very well?